Hello, welcome to your electron transfer and ionic compounds homework. Let's go ahead and get started here. Okay, can the following elements combine to form a compound? We're simply going to put yes or no, or in my case Y or N. Let's see what we got here. The first one is magnesium and aluminum. Here's magnesium, a metal. Here's aluminum, also metal. Remember, metals don't combine with metals. As I say, boys don't dance with boys, so that's going to be a no. The next one we have is oxygen, a nonmetal, zinc, a metal. Boys and girls, they can dance? Yes, indeed. Barium and sulfur. Well, here's barium, a metal, sulfur, a nonmetal. So in that case, yes, they can. The next one we have is neon and lithium. Well, neon is a noble gas. Noble gases are snooty. They don't combine with anybody. They already have a full octet of electrons, so the answer therefore is nope. Then what we've got is calcium, which is a metal, and carbon, which is a nonmetal, so therefore they can go ahead and combine. Next one we've got here is uranium, which is a metal, and remember it fits up in here, which is on this side of the stairs. So we have a metal, and we have fluorine, a nonmetal. So yes, that's no problem. The next one we have krypton, which is a noble gas. So right now I can tell you the answer is going to be no. And lastly but not leastly, we have sulfur, a nonmetal, and fluorine, which is a nonmetal. And nonmetals can combine with nonmetals. So as we say, girls will dance with girls, so the answer is yes. Although it won't be an ionic compound, it will be what we later call a covalent compound. Now what I'm going to do is I'm going to draw an electron transfer diagram showing the transfer between strontium and iodine. So here's strontium, and it is going to try to get rid of 2 electrons. So first I'm just going to draw SR, and I'm going to draw I. Now iodine, I can see from over here, it wants to gain 1. So here is an electron leaving strontium and coming over to iodine. Iodine's happy now. Iodine doesn't want any more electrons, so strontium, as much as it wants to give another electron to iodine, it can't. Iodine now has the noble gas configuration of xenon, doesn't want any more, so strontium is going to have to give that other electron to another atom of iodine. And therefore what we find is the chemical formula, remember, put the metal first, boys first, so I'm going to say the chemical formula is going to be Sr, and how many of them do I have? Well, I have 1 of them, so I just leave it alone. And then I'm going to put iodine second, and since I have 2 of them, I'm going to put a subscript of 2. That's the chemical formula. Now the name of the compound is, I say the name of the metal ion, which is strontium. And if I look, it only forms a +2. It doesn't form anything else, so I don't use any Roman numerals, so I'm just going to say strontium. Sorry, I don't have my stylus, so that's not so bad. And then iodine changes its name to iodide. Alright, number 3, I'm supposed to draw an electron diagram for the transfer of electrons between phosphorus and potassium. So what I'm going to do is I'm going to put phosphorus here, and I'm going to put potassium here. Alright, now let's look what they want to do. What I've got is this. I've got potassium has 1 valence electron to get rid of. Phosphorus wants to gain 1, 2, 3 to look like argon. So the potassium only has 1 electron to get rid of. That potassium's done. Now phosphorus wants to get 2 more. So what I have to do is I have to bring in another potassium here. It's going to give an electron here, and then a third one over here to give another electron. So if you notice, each potassium got rid of 1, which is what it wanted to do, and the phosphorus gained 3, which is what it wanted to do. So everybody's happy, so let's write the chemical formula. Now, I put the positive one first, so remember, the metals go first, and here's a metal, so I'm going to say K. There's 3 of them, 1, 2, 3. So I'm going to say K subscript 3, and then P for phosphorus. And there's only 1 of them, so I leave it there alone. Now the name of it is, I look here, and I see there's only 1 possible charge for potassium, it's +1, so I don't need to use Roman numerals. So I'm just going to write potassium. Oh, I wish I had my stylus. And phosphide. Sorry for the ugly handwriting. Okay, number 4, we're going to do it for calcium and carbon. Here's calcium. It wants to lose 2 electrons. Here's carbon. It wants to gain 1, 2, 3, 4. So, first I'm going to draw a calcium here. And I'm going to draw a carbon over here. Now, each calcium wants to get rid of 2, but carbon wants to gain 4. So it can accept these 2 here. So I'm going to go ahead and say 1, 2. Now the calcium is happy. It got rid of its 2 electrons, and it now looks like argon. But carbon's not happy, because carbon at this point only looks like oxygen and needs to gain 2 more to look like neon. So the answer is bring in another atom of calcium, send over 2 more electrons. Now everybody's happy. Each calcium got rid of 2, the carbon gained 4. So the chemical formula, I'm going to put the calcium first because it's a metal. So I'm going to put Ca, and there's 2 of them, and the carbon second, and there's 1 of them. Now to name this, I'm going to, calcium, if I look, only forms 1 ionic charge, so all I had to say is calcium, and carbon is going to be carbide. And maybe someday you'll get to work with calcium carbide. It makes an explosive gas. It's quite fun when you put it in water, but be careful with it. Alright, now for number 5 on the back, here's what we've got. We've got sulfur and iron. So sulfur is a -2, meaning it wants to gain 2 to look like argon. Iron is a +3, means it wants to get rid of 3 and look like argon. So I'm going to put the iron here, and I'm going to put the sulfur here. So the iron wants to get rid of 3. It gives 1, it gives 2 to sulfur, but you know sulfur says I'm not taking any more because at this point I've gained 2, I look like argon, I will not take a 3rd one. So therefore that 3rd one has to be given to another atom of sulfur. Now at this point the iron's happy because it got rid of 3, and we can see here that's what it wants to do. It wants to get rid of 3. Sulfur, on the other hand, is not happy because it wants to gain 2, not just 1, because at this point it just looks like chlorine, it wants to look like argon, so it needs another electron, and iron is the one who gives them away, so I'm going to bring in another atom of iron. I'll try to make a better Fe this time, and give 1 to sulfur. Now that sulfur at this point is happy. It's got 2 electrons, so it doesn't want another one. Iron, on the other hand, wants to get rid of 3, not just 1, so I have to give those to another atom. So I'm going to bring in another sulfur. You might think it's going to go on forever, but it's not. 1, 2, and we're done. So at this point, I need to write the chemical formula. So I put the positive one first. The boy goes first. That's iron. So I write Fe, and I have 2 of them. So I'm going to put a 2 down below here as a subscript. Then I'm going to write the S for the sulfur. The nonmetal comes second. And I see I have 1, 2, 3 of those, so I'm going to put a 3 down here. Now when I name it, I have to be careful in this case because iron, in addition to making a +3, could also make a +6 or a +2. So I have to use Roman numerals to be specific. So I'll say iron. In this case I put Roman numerals 1, 2, 3. And then I'll write sulfide. Okay, for number 6 we have tungsten and oxygen. Here's tungsten. It normally makes a +6, although it can make several other ions, so I have to be careful there. And oxygen is always going to be -2. So oxygen wants to gain 2, tungsten wants to lose 6. So let's try this here. I'm going to put tungsten here. It used to be wolfram, which is why it's a W. I'm going to put an oxygen here. Now tungsten wants to get rid of 6, but the oxygen will only accept 2. So after I give 2 to that oxygen won't take anymore. It's beautiful now. So I had to bring in another oxygen and give it 2 more electrons. It's happy, but tungsten still isn't, so I bring in yet another oxygen and give 2 more electrons. Now everybody's happy. The tungsten got rid of 1, 2, 3, 4, 5, 6, and each oxygen gained 2. So everybody's happy now. I go ahead and write the chemical formula. What we have is W. Tungsten is the metal, so it goes first. W. There's only one of them. Then I put the oxygen second, and there's 3 of them, so there you go. Whoa, 3. What is the name of this compound? Well, W is tungsten. Tungsten. And I have to specify that this is tungsten 6 because there's a bunch of other tungstens out there. And then oxygen is going to be oxide. Alright, number 7 should be interesting, not because sulfur, which wants to gain 2, but because niobium wants to, if I look here, niobium wants to lose 5. So I'm going to start with the niobium. Here it is, NB. And I'm going to put a sulfur next to it. And sulfur wants to gain 2. So niobium is going to go, well, here's 2. And sulfur is like, I'm done. So I need to get rid of 3 more from niobium. So I'm going to bring in another sulfur. And niobium is going to give it 1, 2. Now niobium's not done. It needs to get rid of another one. So I'm going to bring a sulfur in over here and give it 1 more. Oh wow, that niobium got rid of 5, but this sulfur here is not happy yet because it's only gained 1, it wants to gain 2. So guess who gives away more electrons? And that'd be niobium. So I'm going to put another niobium over here. Sorry for the awful drawing there. And give sulfur that extra electron. Now that sulfur's happy because it's got 2, but niobium's not. It's got to get rid of 4 more. So I think you can see where this is going. I'm going to bring a sulfur in over here. Give 2 electrons there, add another sulfur over here, and give away 2 more electrons. Now look, everybody's happy. So niobium, being the metal, the boy, is going to lead. So I'm going to put NB, and I have, if you look, 2 of them. So I'm going to put a little 2 here, a subscript of 2. Then I'm going to put sulfur. Let's see how many sulfurs I have. I've got 1, 2, 3, 4. I've got 5 sulfurs, so I'm going to put a 5 here. And then the name of this compound, if I look at niobium, niobium can form a +5 or a +3. So I have to be specific. I have to say niobium. And then I have to use Roman numeral 5, which is a V. And then sulfur is going to be sulfide. Alright, last one. This time between arsenic and aluminum. Here's arsenic. We can see it's going to be a -3 because it wants to gain 3 electrons. Aluminum, I see here is a +3 because it has 3 valence electrons, and being a metal, it has to get rid of them to look like neon. So here we go. Arsenic. It's going to go here. Arsenic. Look, I found my stylus. Haha. And here's aluminum. So aluminum apparently wants to get rid of 3. And arsenic wants to gain 3. Hey, I see a deal working here. How about this? 1, 2. Aluminum gives 3. Arsenic takes 3. So the chemical formula is AlAs. Alas. Now, what is the name of this? It would be, let's see, I gotta move this out of the way. Okay. Aluminum only forms a +3. It doesn't form anything else, so I don't need to use Roman numerals. I'll just say aluminium. Aluminum. That's a terrible aluminum. Aluminum. And then arsenide. Arsenide. A D-E.